Okay, YouTube, in this video I'm going to introduce what we call the half angle formulas. We've recently been talking about the double angle formulas, and what they were good for, basically rewriting, sine, cosine, or tangent of a double angle in terms of single angles. Well, these formulas do much the same thing. These half angle formulas, what they essentially do is say if we were to take the sine or cosine or tangent of some angle being split in half, we could rewrite this using an expression that involves just a single angle, which is what we often deal with, just cosine of a single angle. So in this video, we're going to use these half angle formulas and just kind of demonstrate how they work, but to evaluate for the sine, cosine, and tangent, say, of 165 degrees here. So let's go ahead and start by writing that down. If I wanted to find the sine of 165 degrees, the cosine of 165 degrees, so we say cosine of 165 degrees, as well as the tangent of 165 degrees. If we are going to use these half angle formulas, the important thing is that we recognize, well, we're going to rewrite it in terms of just the cosine or the sine, some expression involving cosine or sine, but of a single angle. So the thing that is important to recognize here is this: in each of these instances, we are starting with the understanding that this angle right here is actually u over 2. That's what this equals. So this u halves, this angle 165 degrees, which, by the way, of course, is not to be found on the outside of this unit circle. 165 degrees is not here. It's somewhere between here and here. But we could say if that's u over 2, if u over 2 is equal to 165 degrees, then what would the u be? Because we're going to need to know this u when we rewrite these expressions with respect to u. And so if we were to take both of these sides and double them, I mean, we could just do this mentally, but we'd say, well, then it would imply that when we write these in terms of u, our u will be 330 degrees. And again, the benefit to doing this, I guess, is if I pull this unit circle back out here, is that we absolutely know the cosine, the sine, and can find the tangent of 330 degrees because it is one of our common angles on the unit circle. It has a 30-degree reference angle. So since our u is 330 degrees, we're going to take this expression, which, by the way, is sine of u halves, is equal to plus or minus the square root of 1 minus the cosine of a single u all over 2. So now, when exploring this, we would say, well, then our u in this case is 330 degrees because this is technically u halves. So we're going to rewrite this as plus or minus. And we say, okay, well, this is 1 minus the cosine of 330 degrees all over 2. So now, as far as what the cosine of 330 degrees is, we could say, well, it's got a 30-degree reference angle, as a matter of fact. So the cosine value there would be root 3 over 2. And it terminated in the fourth quadrant, so cosine is positive there, so root 3 over 2. So we're just going to go ahead and rescribble this, and what we end up with is something that does need to be simplified, but has an exact value. So we say this is positive root 3 halves. This is all over 2. And so we would get this here, we'd say plus or minus. Now, if I found a common denominator, it would be 2 halves minus root 3 over 2, all of this, okay, over 2. And if we multiply now by the reciprocal, we get the square root of, this would be, let's see, 2 minus root 3 over 2 on the top times the reciprocal at the bottom, which is 2 over 1, or 1 over 2. And so we end up with this right here. We get the square root of, let me try to draw this more cleanly. We have now 2 minus root 3 times 1 is 2 minus root 3, and this is all over 4. And so I know that this looks like a complex expression because we have multiple roots here, but this is essentially what we end up with. And this can be verified, as a matter of fact, using sum and difference formulas as well. So let's go ahead and take a look at the cosine of 165. At least our half angle formula here is said we're going to rewrite this as plus or minus 1 plus the cosine of u over 2, okay? So when we rewrite this here, we say this is plus or minus. So this is the same expression we just dealt with, but you'll notice that it's 1 plus the cosine of our u, which in this case is twice what we started with here, all over 2. So doing this simplification all over again, I suppose we could say you get the same exact answer once you go through all of this work right here. It is just that we have a positive here, instead of a negative. We have a sum instead of a difference. So we get 2 plus root 3 over 4. So I always encourage people, if you know the sine of 165 here using half angle formulas, well, then doing the cosine is really easy because you can just change that to a sum. Now, looking at tangent values, we say tangent of u halves is equal to any of these expressions you choose to use over here. And they're all going to turn out the same answers, but I would say that when given the choice, these bottom two here, one of the things you're going to have to deal with is the fact that one of them has a cosine, that one has a sine. If you know both sine and cosine of the single u, then I suppose you would be in really good shape, which we would be able to find those here. But if you only knew, say, the cosine, we could chase after this top form right here. I am actually going to use this one right here because it has a monomial divisor. I like when that happens, and I think it'd be the easiest one to use, most efficient. I could use any of them. So we have this. We have the tangent of u is equal to, in this particular case, I'm choosing to use 1 minus the cosine of u over sine of u. So we, in this case, get 1 minus the cosine of u over the sine of u. Actually, I put a little too much room there. Cosine of u, or u in this case, is 330 degrees. Well, we're able to determine right off the bat over the sine of u, and the sine of 330 degrees. There. So now we'll go ahead and evaluate this. We know that these have a 30-degree reference angle, and that the cosine of a 30 is root 3 over 2. We can also go look at the unit circle here. We say cosine at 330 would be root 3 over 2, positive root 3 over 2, so we get root 3 halves. And then sine of 330, that should be a half. If this came out to be root 3 over 2, then the sine of that angle would be that half. But we can look here, and we say sine of 330 is a half, is a 30-degree reference angle, so sine of 30 is half. But it terminated in the fourth quadrant. All students take calculus, so it is negative. So we get a negative a half here, so negative a half. So we're going to go ahead and do this. We're going to at least, with the top here, we're going to find a common denominator. So we would say 2 over 2 minus root 3 over 2 all over negative a half. Putting all this in parentheses here. So the top becomes this, 2 minus root 3 all over 2. Okay, that times the reciprocal of the bottom, which is negative 2 over 1. Oops. So we get our 2's to cancel in this particular case, and we get a positive 1 and a negative 1. So what we end up with really here is this. Once we distribute this negative 1 through, we get a negative 2 plus root 3. And this would be our exact tangent value of 165 degrees. And again, this could be verified with some indifference formulas as well. Cheers.